Namaste. I, Anthixotropy, Assistant Professor in Jyoti Vidyapith Women's University, Jaipur, Faculty of Pharmaceutical Sciences, is here to deliver the lecture on rheology. Now, today's our topic is rheology. This is the unit of second in physical pharmaceutics subject. Rheology. Now we are going to study about rheology. What is rheology? Rheo, that means to flow, and logos, it means science. And if there is a logy or ology, that means the study of. So now we summarize it. Then we can say what is rheology? The study of the science or the science of flow. Okay, thus rheology is the science that concerns with the flow of liquids and deformation of fluids. What this thus rheology is the science that concerns with the flow of liquids and deformation of solids. Right? The study of viscosity of true liquids, solutions, dilute, and concentrated colloidal systems is known as rheology. It is involved in the mixing and flow of materials, their packaging into containers, the pouring from the bottle, extrusion from a rub tube, or a passage of the liquid to a syringe needle. It can also affect the patient's acceptability of the product, physical stability, biological availability, absorption rate of drugs in the gastrointestinal tract. It influences the choice of processing equipments in the pharmaceutical system. Now, there are two categories uh, deformation and formation flow. Now, they are of two types, Newtonian flow and non-Newtonian flow. Newtonian flow is also known as Newtonian law of flow. The higher the viscosity of a liquid, the greater is the force per unit area. Force per unit area can be also said shearing stress required to produce a certain rate of shear. What is shear now? Shear is a stress which is applied parallel or tangential to a face of a material as opposed to a normal stress which is applied perpendicularly by shear stress measured in SI unit, which is this measuring unit is Pascal. We can shear stress can be measured in Pascal, and for Pascal commonly used symbol is tau, right? And expressed in other quantities, tau is equals to F upon A, right? Now, a shear stress is applied to the top of the square while the bottom is held in place. The stress result in a strain or deformation, changing the square into parallelogram. Okay. Now, a Newtonian fluid named for Isaac Newton is um, is whose stress is a fluid whose stress versus rate of strain curve is linear and passes through the origin. The constant of proportionally is known as the viscosity. The graph that is plotted in between shear stress, which is denoted by tau, and shear rate is known as Newtonian model. In common terms, this means the fluid continues to flow regardless of the forces acting on it. For example, water is Newtonian because it continues to exemplify fluid properties, no matter how fast it is stirred or mixed. For a Newtonian fluid, the viscosity by definition depends only on temperature and pressure, and also the chemical composition of the fluid is if the fluid is not a pure substance, not on the forces acting upon it. Now, what is non-Newtonian fluid or non-Newtonian law of fluid? A non-Newtonian fluid is a fluid whose flow properties are not described by a single constant value of viscosity. Many polymer solutions and molten polymers are non-Newtonian fluids, as are many commonly found substances such as ketchup, starch suspension, paint, blood, and shampoo. They are what? Non-Newtonian fluids. Okay. In a non-Newtonian fluid, the relation between the shear stress and the strain rate is non-linear and can even be time dependent. Therefore, a constant coefficient of viscosity cannot be defined. Okay. And what are the types of non-Newtonian fluids? First one is Bingham Plastics. What are these Bingham Plastics? They have linear shear stress and strain relationship which require a finite yield stress before they begin to flow. For example, the shear stress strain curve doesn't pass through origin. For example, clay suspension, drilling mud, toothpaste, mayonnaise, chocolate, and mustard. The classic case is ketchup, which will not come out of the bottle until you stress it by shaking. So, the types of non-Newtonian fluids are very important. So, please study about these types of non-Newtonian fluids, right? And now, Bingham plastic model has also the same graph as Newtonian, which is in between shear stress, which is represented by what? Tau, and shear rate. Okay. Now, second one is pseudoplastic flow. Polymers in solution such as tragacanth, sodium alginate, methyl cellulose, which is also denoted by what? MC. Viscosity decreases with an increase in shear thinning caused by the realignment of polymer and or the release of solvent associated with polymer. Now, the third one is dilatant flow. In this, volume increases when shear thickening. Suspensions containing high concentration of small deflocculated particles, right? In shear stress strain for all fluids, the graph is between shear rates, which is denoted by s to the power minus 1, and shear stress, which is denoted by tau. And dilatant flow, Newtonian fluid, pseudoplastic fluid, and Bingham plastic graph can be discussed over there. There are also fluids whose strain rate is a function of time. Fluids that require a gradually increasing shear stress to maintain a constant strain rate are referred to as rheopactic. Okay, and opposite case of this is the rheopactic. But if we take the opposite case in which a fluid that thins out with time and requires a decreasing stress to maintain a constant strain rate, that is called as thixotropic. Okay. Now, the definition of rheopactic and thixotropic will come in the examination, or someone ask, or somewhere in interviews the question will be arise, what is the difference between rheopactic and thixotropic strain rate. Okay. Now, in thixotropy is the property of some non-Newtonian pseudoplastic fluids to show a time-dependent change in viscosity. The longer the fluid undergoes shear stress, the lower its viscosity. A thixotropic fluid is a fluid which takes a finite time to attain equilibrium viscosity when introduced to a step change in shear rate. The term is sometimes applied to pseudoplastic fluid without a viscosity or time component. Many gels and colloids are thixotropic materials, exhibiting a stable form at rest but becoming fluid when agitated. Okay. So this is about thixotropy, rheotropy, and what are the rheological behaviors. Right now, we are discussing about the what are the various applications of rheology. Okay. Now, What are the applications? There are various applications. For example, Poloxamer vehicles that is used in tear solution for treating dry eye syndrome, and in preparing suppositories, release and absorption is depend on rectal temperature. So Brookfield viscometer is used to study characteristic of triglycerides based at various temperatures. And in the formation of emulsion, also Brookfield viscometer is used to uh, know the rheological behavior of triethanolamine stearates at various temperatures for the stabilization of emulsion. If we do the stabilization studies, so Brookfield viscometer is used to study the viscosity of triethanolamine stearate and other excipients. Okay, now in cosmetic sticks, viscometer is also used. Okay, and in tablet excipients, microcrystalline cellulose is used as granulating agent. So mixture torque rheometer is used to measure torque changes as water is added. And in lamination, in case of lamination process, various stages, softening point of the resin starts to soften and flow as elastic material. So drop of viscosity is noticed. Okay, material is not most fluid and reaction rates start to increase as viscosity starts to build as the resin starts to gel. At gel point, 10 delta is 1, and this is denoted or this is measured by a parallel plate rheometer. So here rheometer is used, right? Now in suspensions, settling of particles is measured by Brookfield viscometer, which is fitted with helipad attachment, consists of rotating T-bar spindle. Dial reads resistant at various levels of suspension. So, in stability studies of suspension, the viscometer is used over here, and also in ointment consistency measured by Borel-Sever rheometer with helipad attachment. Ointment is loaded into a cylinder and extruded with measured force. Amount extruded is measured of consistency. Here also an application of rheometer or viscometer. Okay, in aerosol viscosity is also measured by Brookfield viscometer, and in the preparation of paste where capillary extrusion viscometer for the viscosity measurement of fish protein paste is done. Okay, now uh, this is all about the applications of viscometers. Now, what are the latest type of viscometers and rheometers? Because it can be an important question for GPAT, where they can ask what is the latest type of viscometer and rheometer. Hake Rio Stress 6000, which is a universal rheometer in which variety of temperature control units are there. Temperature ranging from -80 up to 500 degree is available. So there is flexibility of temperature. And second one is Brookfield viscometer, where different type of viscometers are there. They have T-bar, vane spindle and disc spindle in it. And due to this spindle, the viscosity is measured in different steps. Okay. Now, what are the significance of um, helipad stand? What is this helipad stand, and what is the significance? Substances with yield values unsuitable for viscosity or consistency measurement with rotational viscometer. Rotating spindle, be it cylinder, disc, or paddle, will create channel and produce negligible and meaningless torque. The Brookfield helipad stand is designed to slowly lower always rotating T-bar spindle. By always cutting into fresh material, the problem of channeling or separating is eliminated. So this is the major significance of helipad stand. Okay. Now we are now this is all about this lecture of rheology. Okay. If you have any queries about this lecture, please let me know and make a short note about this lecture. And I describe all the important questions in this lecture. So please note it down. So thank you. Thank you so much.